Hello and welcome to another Solana tutorial. I found another really interesting question on the Solana Stack Exchange that I want to answer today. And the question is, how can you tell in an on-chain program if a previous transaction failed? Because as we know, if a transaction fails, all the state changes get reverted. So you can't rely on that transaction writing something to an account. But how can you still tell the difference whether a transaction was executed but failed versus the transaction was never even submitted or didn't find a way in the block, so it was never executed by the cluster? How can we tell that difference? That's what I want to explore today. And while we do that, we'll have a look at Anchor development, we'll have a look at Kodama again, because I will need those two things to quickly test some stuff. The question in question is this one. If he has a transaction which fails, he wants to be able to tell in your program that transaction failed versus it succeeded or has never been even submitted. And as he already correctly states, if it was checking for success, then it's simple. You just write to some account and then you can check that account. And only if it succeeded, the change will be visible in the Solana state. And then they're already thinking of CK proofs or whatever. And another answer suggests a two-step intent pattern. So you say you want to do something and on success you clear that and otherwise the intent remains. But it's not quite the same as checking that a transaction fails because maybe the transaction didn't arrive yet that fails. So you can't tell the difference here. Or some off-chain attestation, yeah. Off-chain, you have access to the ledger, but in the program, you can't access the ledger. So you can't check for a transaction signature. You can't check for past state. You only have access to the current Solana state, not the ledger. And yes, cryptographic proofs or whatever. Complicated. I have simpler solutions. Let's get to them. Because I answered it at 1:37 at night, and now it's 1:37 in the day. Good time to answer questions, eh? Yes. Okay, so let's get to it. Let's call it fail check. And in here, create an anchor program. I want the person to deploy, Johnny Depp. And I want my checker program. And then I copy this into here and this into here. So we have a checker program. And what that program will do is it will have a check instruction. And then I'm gonna also give it a fail instruction, which we will call in order to make a transaction fail. I could also do something like send 1,000,000 sol to some account and then the system program will make it fail. Or I could use a lighthouse transaction to make it fail or something. Or I just use my own program, which just does error. Let's do it the anchor way. My errors made program fail on purpose. We just make the program fail on purpose. There you go. That's how you do that. And we put the fail context, which has no accounts. And then we'll have a check context. Or now the context contains accounts. Maybe I should call it fail accounts. I never know what to call those. Let's call it accounts. Okay, we'll get there. For now, we have no idea about previous transactions. Nothing. We can't access the ledger. We only know the current state. Let's get that program built and deployed and get a script to call it, and then we can really start. So this is just set up now for a bit. My fail checker anchor build. Let's see what we get here. And we're gonna build with warnings, of course, but that's fine. And then we have the SO file that we can deploy. That's great. Now we also build the IDL and we see what we get there then. Here we go, IDL build. So we got this my fail checker JSON IDL. We also get the types. Yeah, that's nothing new. That's just the IDL in type. Okay, let's revisit how Kodama works to get from this IDL to the generated code that I can call from the kit. Just as practice, because I forgot how that's done. Solana, coming from Anchor. Let's see what would happen if here I just say pnpmi Kodama. I still don't have Kodama in it. I have it, I just don't have it here directly. The CLI binary is also included in the main Kodama library. I have it in there, but I still don't have... Wait, if I have a new one? Nope. So, would I need to do this? That I could do. There's the Kodama CLI. And I'm sure I could add that to the path or somehow get that properly, but I'm not sure how. So that's how I'm gonna run Kodama now, for now. So I'm gonna do this init. Welcome to Kodama. Where is your IDL located? It's actually, glad you ask, in my fail checker slash target IDL target. Which script preset would you like to use? JavaScript. Where should the JavaScript code be generated? Client Java source generated. Yeah, why not? Yeah, whatever. Yeah, whatever. Install dependencies. Yes, sure, why not? That's quite simple. There we go. Configuration file created. So we have this Kodama config file that just says, here lives my IDL. Use that script from Kodama renderer to generate the JavaScript stuff here. And it suggested here, hold on, for simple anchor, I just need that. Path to my anchor IDL JSON. Okay, so I need to say to the IDL JSON. So I should probably here say target IDL slash my fail checker JSON. And then I should be able to say Kodama, wait, this run needs an import attribute of type JSON. What's an import attribute? What about doing this then? If I literally, instead of that, I provide just the path to the IDL, would that run? No. Let's Google that. No. Oh, don't do anything in high quotes. That's not good. Okay, Googling is somewhat useless. Maybe that will help. Let's create a tsconfig. Maybe that changes something. No, it does not. Because we're somewhere different. Ah, that's just annoying. TypeScript BS. What if I run Kodama like this? Already exists. And then I can do run JS. No, same thing. I'll just, instead of make a Kodama JSON, I'm gonna make a JavaScript. Will that fix it? Unexpected token export. God damn you. I'm just gonna provide you the IDL path manually then. Also screw this. Just gonna manually provide you the path. Needs an import attribute of type JSON. Also that needs an input. You know what? Screw Kodama. But it can't be so difficult. Why is it so difficult? Let's do a separate client part and here PMI and types node and Solana kit and whatever else we might need. And then in the client we call program, which, you know, nothing unexpected here. Let's set this key and use this key here. We run with a deployer as well. Why not? You know what? While we're here, let's do a fee payer. Fee PJ. Okay, so I can call the program like this, but since it's an anchor program, this is just not gonna work. I can show you. Gonna anchor deploy. Oh, gonna need to tell it to deploy to DevNet with this key pair. Oh, it's automatically writing IDL data on chain. That's new. Cool. Why not? In this IDL account. That's a topic for another video, but that's cool. We'll have a look at that at one point. Anyway, so that program is now deployed. I could theoretically call it, but then it will tell me, hey, this is not an instruction you're calling. I'm going to show you. If in my client I would call the call program script account not, oh yeah, my fee payer that I created doesn't have any sol, so that's already an issue. So can I Solana airdrop a sol to my fee payer? Okay, so I will Solana transfer one. Nah, that's too much. What's my balance? Anchor programs are expensive, yo. Solana transfer to this address 0.1 sol should be enough. There you go. Okay, try calling the program again. Now that account exists, but instruction fallback not found. We're trying to call an anchor instruction that just doesn't exist because we have check and fail and we're calling nothing because we don't provide any data here. That's why doing it with Kodama would be really nice. So we could build the transactions directly with those, what are they called? Those generators, those codecs. So I don't need to do it manually. I could do it manually. I know how to do it. We've done that before. We just need to put those bytes into the instruction data and it would be fine. But I also would really like to find out how it's properly done with Kodama. Fine, let's create our own Kodama script again. Ugh, if the CLI doesn't want to work, then fine, let's do that stuff. Create Kodama. How about we use this? Just gonna steal Mike's code and import those two things. Render JavaScript visitor is deprecated. Okay, let's see if we can get until here though. Transform error. Top level await, currently not supported. There's no top level. Oh, there is a top level await. Fine. Okay, that works. But how do I write it now? What do I do with this thing? What does accept do even? With a visitor. So render JavaScript visitor is deprecated. What am I supposed to use instead? Use render visitor from Kodama renderer.js instead. Okay, render visitor, and this render visitor can have a path. Okay, perfect. And that will do. Perfect. So do I now have a JavaScript client index? Yes. And that has all my instructions? Yes. Nice. Managed. Just took me an hour to get Kodama to work again so we can properly work with Anchor. And now we can finally run our program. Yeah, I know, it's a bit Solana development. It takes some time to get started. We'll get to the thing with checking for the failed transaction. Don't worry, we get there. But it's probably also very helpful to revisit Kodama, because if you write Anchor programs, that's a very helpful tool. So anyway, in my call program, I can now import that stuff from here. So import from dist JavaScript client. I can import my, what do I need? Let's just do a get fail instruction. And then here I do a get fail instruction, which shouldn't need anything because it should have everything provided. And let's see if we can call the program. Yes, look, error 6000, made program fail on purpose. Instruction fail. And that's just a simulation that wasn't persisted because I simulate that transaction and return on error. Let's first not do that. And second, when we send it, also skip pre-flight, because otherwise the RPC will do the check and throw it out. And if I do both of that and I call the program, then I will actually send the transaction. That fails, but is persisted on the cluster. So we have it in the ledger. We see what happened here, that the anchor error was thrown and we made our program fail with this error code. And that transaction really failed, but it was executed. It's not like it was never submitted. So how can we check the difference between a transaction that was just never submitted to a transaction like this that was submitted but then failed? And as we correctly stated in the beginning, if I were to write something like in my program here to one of the accounts, I could, put in an account and then write something. Let's add that. Why not? Let's init an account state, my state. Okay, init will need more. Fine, have a payer and payer be the payer. And then let me guess, you also need a space. Let's say 1 byte, because I can. Yeah, and then why not? Let's make it a PDA with seed state underline 2 bytes. And then we're gonna get instruction data, 2 little endian bytes. What else? I'm pretty sure I'm still doing something wrong here. I think that's named differently, but we'll see. Oh yeah, you still need the system program as well, because if we do stuff with, oh, by the way, the payer should also be mutable. And then we need still the system program system. Okay, there we go. 2 bytes doesn't exist. S bytes, what was it called? String, yeah. And then this thing, okay, fine, I borrow this. Sure, whatever. And my state still doesn't exist because I didn't tell you what the account looks like. Let's do that. And let's do it like I found in this example, that we use the prefix like that. That makes it also a bit more efficient than what I'm doing up here. How do I do that then? I want you to, why is this always so complicated? Now it expects that to have the same length. What if I do this? Can I not give you a fixed length? Is that better then? Yeah, okay, fine. I just not give you a fixed length. Fine. If it makes it work, we'll see if it works. I'm blowing up this example, but it will be useful in a second. Let's actually call this init again and use init up here. And then let's also be nice and do a success with the same accounts. Basically doing the same thing. I'm not even going to store the bump. I need to store 8 plus 1. But maybe the 1 I can calculate from the my state init space. Then it will calculate it here. And I just store success a byte. And the idea is on success or even on failure, I will write to this state account success field a 1. So I'm assuming that this will work both on success and on failure. We write the 1, just that in the case of an error, it will not be persisted, but in the case of OK, it will be. So let's have a look at that. Let's first anchor build again and deploy, and meanwhile run Kodama again. To 200 transactions. It's just ridiculous. Anyway, welcome to Anchor development. Okay, so why did Kodama not run? Kodama error anchor argument type missing. Index is missing for an instruction definition. That is a very fair point that Anchor didn't give me. Or did it? No, Anchor was like, yeah, whatever. But the IDL was like, hey, there's no argument for index, which true, I didn't give you that. What did I say? It's a U64. That I use that for tracking which transaction it is, because I might have different ones. And depending on the index, I will create a different account because I will have different seeds here. That's what I'm using that for. Okay, so then fine, build again, deploy again, and then create the Kodama stuff. There we go. So now if we call the program, this now needs to know the input string config failed. Wait, what? An argument input was not provided. Okay, input index payer state. So you need to know who pays, what's the state account, but that should be auto-derived. No, why? I mean, I'm using Kodama such that you auto-derive that stuff. I don't want to do that myself. Wait, do I need to tell you that in the anchor toml? Features seeds true, something like that. And my IDL should have accounts, state, seeds. There we go. And then the index. It's in the IDL, in the Kodama IDL. Maybe the Kodama IDL doesn't support that. Let's check. Discriminator index. Discriminator is the fail discriminator that it gets. The index is just a U64. That's the account stuff. Yeah, it's annoying that I still need to provide all of that. I mean, the index, I'm happy to provide it. I'll just say 1. And the payer, I'm also very happy to provide that. That's my payer key pair or payer address. Or what do you need? Not assignable to transaction signer. Oh, you need a transaction signer? Sure, then have a transaction signer. And the state account, fine, I'll need to get it myself. It's not smart enough to derive that, unfortunately. State account is... Do you think I get that from here somehow? No, because it's just in the seeds. Damn, then I need to do this manually anyway. Why am I going through the effort of using Kodama? Ugh, man, I should have just done a Pinocchio program and everything would have been so much simpler. Anyway, so get program derived address then for the following program. I'm sure that's somewhere in here as well. Fail checker program address and the following seeds, which is a list of seeds, and the seed again can be a string. Okay, that string sadly is not somewhere in my IDL though, the state underline. Let's do transaction index, do 1, so we have the same value here as we have here. Number is not assignable to seed. Okay, what is assignable to seed? What is a seed? A read-only uint8 array. Right, so then we get a U64 encoder and encode that index. Fair, let's go. Then we should get that account, which is a promise that we can await. And then we have the address and the bump, which I don't give a shit about the bump. And then we have the actual account, which we put in here, which now should work, right? So if we call the program, we send that transaction fails. It did try to create this account, but it didn't manage because the state was reverted. This account still doesn't exist. However, if we go with, instead of the fail, we do a get success instruction with the same parameters, because the success takes the same things as the fail, literally does the same, except it doesn't fail the transaction. So with that, if I call the program, I can actually send this transaction and it will give me success. So in the Explorer, that's gonna look like this, success. And this time, this account was actually created. So it exists now, it has 9 bytes. And if we read it, Solana account this, then we see that there, after the discriminator, we've written 1 into our state. And that is what we can use to check whether or not the transaction was successful, right? We have written something to state. So if we just want to know, has that transaction with index 1 been successful? Then in my check, we have no idea about previous transactions. Well, let's get an idea about previous transactions by also using the index here and by also using the state account in the check accounts. except we're not gonna initialize it anymore, but we're gonna use the same seeds. Gonna give you this, here you go. And that's it, it just needs that state to check. Then it can do, well, if context accounts state success is 1 or whatever is anything else than 0, whatever it might be, then I can say message the transaction was successful. And we're talking about the previous transaction, not the current transaction. The transaction in question, I'm gonna call it the previous transaction, or the transaction with index, and then I give you the index here. Sure, why not? And of course, otherwise, else, let's say we don't have information about that transaction with index so and so. Anchor build and deploy, run Kodama again, and then we do a check where we do the same thing, but we get a check instruction which just takes the state, which is the state account. Oh, and it needs the index. Okay, transaction index, there you go. And if we run the check, then we see that transaction with index 1 was successful because it can read that account that we created earlier. It can take the state from there and then say, yep, that transaction was successful. But now, what if for the next index, let's check for index 2, and for index 2, we let it fail. So if I now check without having sent the transaction first, we get the, Anchor already errors because the account doesn't exist. Okay, I still have a bug there because it tries to identify that as a MyState account, which I don't want you to. God damn, I know what I'm doing. Check, we only read this account. There. So we make it an unchecked account. I know what I'm doing, and I just don't want it to fail just because the account doesn't exist. And I could create the account up front, whatever. But what I'll do instead is here the state data at index 8. Can't directly access that, unwrap it. But I can only do that if the account exists. How do I check if the account exists? I could do Lampert's bigger than 0 or data length bigger than 0. Let's do Lampert's bigger than 0. Just making sure that the account actually lives. Let's quickly redeploy that. Okay, if we now check, there we go. That's what I'm expecting. We don't have information about the transaction with index 2. So it could be that we never submitted the transaction with index 2, or that the transaction with index 2 failed. In both cases, the account will not exist. So even if I call the program and it tries to create this account, the account 8mu, we try to call it, but it errors. So it will end up still with an account with 0 Lamperts that has no data. It doesn't exist. Same as if we would have never sent that transaction in the first place. So the check obviously will still say the same thing. We don't have any information about that. We only have the information on success. Okay, that was 2 hours of setting this all up and we didn't get to any solution yet. Let's finally get to a solution. Because when we send such a transaction that fails, none of the state is persisted. Although, none of the state? Well, some state is changed. Look at this. The fee payer still fee paid. That's a change in state. So also failing transactions change the state, because the fee payer will still need to fee pay. And we can take advantage of that and use it to check whether or not we did send that transaction, or whether or not this transaction was executed by the cluster, and therefore check if it failed or if it was never submitted. So we could do something like initial fee payer Lamperts. I provide the amount of Lamperts that were on the account before we sent the first transaction that we're interested in. Also, we will need the account though, so we need the fee payer. Might as well put it in here as a signer. Call it the fee payer, specifically fee payer, not payer for any account, but transaction fee payer. If my fee payer Lamperts that are currently on the account are less than the initial fee payer Lamperts, then I can make the assumption that, provided obviously that it's only those two transactions that are being sent. The first one that I'm interested to analyze whether or not it failed, and then the second one that checks. That's an assumption that we hold here, obviously. But as long as that assumption holds, we can here say the transaction with this index failed, or the transaction with this index was not yet submitted, or was never submitted or accepted by the cluster. Maybe it was submitted to an RPC, then the transaction was never executed. Okay. And maybe you could even do, it must be the exact same here. If it's not, if it would be bigger than some other transaction messed with our state. And that can always happen. This is not a perfect solution because anybody can credit Lamperts to an account. So theoretically, if they know what you're doing, they can make you think that this transaction was never submitted, even though it failed, by just topping up the amount that the fee payer fee paid. And then you think it was never executed even though it failed. So it's not a perfect solution, but depending on your use case, if you just want to have a high likelihood that the transaction failed, but you're okay if you get some false positives if someone messes with you or the fee payer pays something else, then, be aware that's not a perfect solution is what I'm saying. But it will work if we just have those two transactions that influence the fee payer. Quickly build and deploy. Rerun our Kodama stuff such that we need to update this because now you also need the fee payer, which is my payer. And then you also need the initial fee payer Lamperts. And how/when do we get those? Well, when we call the program. So before we call the program, we want to do a get account info for my payer and read the Lamperts, and then we can log those initial Lamperts, or we can also say Solana balance for this guy. That's the balance, so that's what we take. So in our check, the initial fee payer Lamperts is this, obviously in Lamperts though, so like this. And now if we check, damn it, that's not correct. Oh, wait, I see, wait, hold on, because it's already subtracting the current transactions Lamperts from here. So I could either use a different fee payer for the check transaction, or I need to adjust for that. Apparently at the point of execution, we're already lower because here, that's the transaction. We did pay this again. We started out with 6, but now it's 1. Okay. So that transaction fee is being subtracted from the account before even the transaction execution happens. Can I adjust for that inside my program directly? I mean, I would need to analyze the compute budget instructions and everything to know what the actual transaction fee is of the transaction. Or I do it up front, or I deliver it, or I use a separate fee payer. Like the fee payer for the check could be a different one than the fee payer for the first one. That's probably the cleanest way to do it. I could, of course, also do minus 5,000 Lamperts or whatever the actual transaction fee is. I adjust for compute unit usage. This is just the base fee, but I'm not using any priority fees, so that's just this. And then it should work. If I adjust that to the current value, then it should tell me if I check, okay, it was never executed. But if I check again, obviously now it will tell me again that it failed because this transaction came in the way. So the cleaner way to do it is to use another fee payer. Let's just use the deployer. I don't want to fund another address. I'm just using this one. So if we update to current balance and we use a different fee payer now for this transaction and we check, then it will tell us some other transaction messed with our state. Oh yeah, because I'm still doing the minus 5,000. That's true. I don't need to do the minus 5,000 anymore. Yeah. No? Wait, what? Oh, I'm providing the wrong fee payer. Yeah, the fee payer is now, oh, hold on, I need the payer and the previous fee payer, which was this guy. And really, it wouldn't need to sign, but as a security thing, I could let it sign as well. So I'm gonna let the previous fee payer be the fee payer here. Okay, so then that should work. So if we now check, there we go. Now we're in the transaction with index 2 was never executed. And I can run that as many times. I can pay for as many transactions here. It will keep saying, nope, it was never executed until I actually call the program, which will then execute that transaction that will fail, but the transaction will be executed, therefore removing Lamperts from this account. Therefore, when I now check again, I can tell, oh, this transaction failed because the Lamperts are now less than what I expect them to be, which was this initial number. So yes, a bit messy with the fee payers, but it works. I can make the difference between a transaction never having been executed versus that transaction having been executed and failed. And the transaction having been executed successfully, that's also easy to tell. If I once call it with success and then I check, then it tells me, okay, this transaction with index 2, I mean, now it was a different transaction that I also gave the index 2 because the index 2 really just references the account and not the transaction. But whatever, I would, increase that every time, but whatever. You get the idea. So this transaction was successful because it persisted some state. That's the easy part. This one is the difficult part. And this one is the part that is also it's not super reliable because, as I said, anybody can top up Lamperts to your account. They don't need to sign with your account to top up Lamperts, and that will mess with you. So if you have a high security use case, then you definitely don't want to use that. This is just for, regular checking, like a plausible, oh yeah, it could be that, or it is likely that the transaction failed. The main point here just being, we do change the state even if a transaction fails, because we do let the fee payer fee pay. And it's not a great solution, but it's a possible solution. However, I do have an even better solution for you if you want to hear it. Do you want to hear it? How about we use nonce accounts? Oh, the nonce accounts, my favorite type of account. Let's use a nonce transaction to achieve a similar thing, but in a more reliable way. Because if we don't just call our program, well, let's leave that. Let's go to transaction 3. If we don't use a regular lifetime using block hash, but instead we use a durable nonce here. So we need a nonce account. So for that, we will have to create a nonce account. Oh, that's in system program. Okay, so I will need to pnpm I add the Solana program system, and then I can import get initialize nonce account instruction, which will already need an account. So I will need to have get create account instruction first. So we will do create account for, I'm gonna create just a random new account, generate keeper signer. So new account is the nonce account. Oh wait, I need to sign for it. So here you go. Payer can pay for it. Program address will be the system program address, and space and Lamperts. Oh, I know this, but do I get it from in here? Get nonce size. No, is that nonce account size or is that nonce block hash size? Nonce decoder sounds like it's the account size. Perfect, that's what I need. Perfect, so I'll just take that. So space will be that. Lamperts, I'm gonna await an RPC, get minimum balance for rent exemption for the nonce size. And that's still so annoying that this gives me a number but needs a big int. Super annoying. There you go. That way we create the account, and then afterwards we make it a nonce account with get initialize nonce account instruction, which again here have the nonce account address, the nonce authority, and this thing now helps me to protect that nobody else can mess with my state while I'm working on this, because only the nonce authority can advance the nonce, such that you can't change the block hashes in other people's nonce accounts. There's this authority. So I'm gonna set the authority to my payer as well, and this it should take automatically, so I don't need to provide that. That should do it, and then I should also log the actual nonce account address because we will need that later. Let's see if that works. Can I create a nonce account? Yep, success, success, success. This is the nonce account. If we have a look at that, that's the authority. My fee pair is the authority. And the block hash in here is this. And this is what we will use as a reference. Same way we previously used the Lamperts. Spoilers. Let's have a step by step. So anyway, this nonce account exists. And in my call program nonced, I can now use this instead of this block hash, use a nonce account, this address, and then I will also import system program stuff here, fetch nonce with the RPC and the nonce account address, which should give me a nonce account, which has the address, but also the Lamberts and the data, which should hold the authority, the block hash, and so on and so on. And the block hash is what's interesting, so I can log this as well. And then back to here, we can provide this nonce. What does that need? The decoded account or the block hash? Account address, authority address, nonce. What are you? Extends string, so I would expect it's the block hash. Okay, so the nonce is, that's the naming here is not ideal. The nonce account, that's the nonce account address. If we're being very specific here, then this is the nonce account, and then the real nonce, so the kind of the block hash is this thing. So from the nonce account, the data block hash. That's probably better from the naming, then it's the same as here. So we provide the nonce, we provide the nonce account address, and we provide the nonce authority address, which is, I haven't decoded that. That's in nonce account data address authority. Address is not assignable to never. What? This is an address. You need what? Has conflicting types in some constituents. I mean, I love the kit, but sometimes this is really confusing. Do you need the nonce account here instead? No, nonce account is not assignable to type nonce string. Okay, so nonce string is a different thing than what I'm getting here, which is an address. This fetch still maybe gives me the wrong type here. And you know what? For now, I'm just say stop messing with my types. Address is not compatible with type nonce. Does nobody ever work with nonces with a kit? Probably not. Nobody works with a kit except for me and maybe you. Codec decode will give me the block hash which has type address, and that's what we get here. Okay, so where does this nonce thing live then? Wait, where do you live? You need a type nonce value. Nonce represents a string that is particularly known to be base 58 encoded value for a nonce. Yes, yeah, that's great. I would love to use such a thing. Can I use such a thing? How do you use such a thing? A durable nonce. Can you create that from a string? This is most likely just a bug in the kit because it gives me that as an address and not as a freaking nonce. Nonsense, I tell you. This is so annoying. But I have done that once before though. I know I've done this before and it felt like it wasn't so difficult. Address is not compatible to type nonce. It's not compatible. Shut up. But there's also not a nonce function, right? Okay. Screw you, TypeScript. This is a string, and then it's a nonce of a string. Do you take it then? No, you still think that's an account. Oh wait, I'm taking the account now. I want that nonce. There we go. Ha! Gross, but will do. This is just I believe this is just a bug in the kit. This should not be an address. It should be a nonce. But anyway, so like this, we can now probably, maybe, hopefully, send a transaction with a durable nonce lifetime instead of a regular block hash. So let's try that. Let's call the program nonced. That works. Look. It took that block hash that we saw in the nonce and it did send that transaction. And it did give us success. So we have a transaction with this recent block hash that we got out of the nonce account and not from recent block hashes. And the transaction worked as you would expect. It created this account. And what we're doing when we use a nonce transaction is we call this advanced nonce, which requires the authority. We sign with that. And then it changes the block hash inside the nonce account. So it changes the nonce of the nonce account. That for some reason we call block hash, which is definitely the wrong name in there. Speaking of wrong names, it's the same as pub key that we use for address. We use block hash for a nonce. But okay. It is. Okay, yeah. It's legacy things. Yeah. But it's certainly not an address. Anyway, it's another 32-byte thing that we just happen to use address as a representative for, which is just stupid, but okay, whatever. So, anyway, we're here. The advanced nonce. Now, check this. I'm gonna go to index 4, and I'm gonna let that transaction fail. And I call my program nonce. Before, though, I'm gonna check my nonce account here. That is the current block hash, the 5DZ. I'm gonna call the program with the nonce. It takes the 5DZ as the current nonce for the recent block hash. And then check this out. The transaction fails. We get error. But for security reasons, system program advanced nonce is still being called and is also persisted. Not the rest. The rest here is red. Whatever happened there, they will drop that. But for security reasons, the advanced nonce must be executed. Therefore, inside my nonce account, I will have, guess what? A new nonce. So a new block hash. Haha! And guess what we can use that for? Yes, we can use that to check whether or not my transaction was actually executed. And then once we know if it's executed or not, we can check for success. And if it wasn't successful, then we can know that it failed. Or we first check for success, and then if we don't have success, we can check if it was executed at all. And if it wasn't, well, it wasn't. But if it was, then we know it must have failed because we didn't get success. So let's implement that. Let's update our program and do a check, a second one, a check nonce that takes check nonce accounts, which this time we won't need the fee payer anymore. The authority is also checked by the advanced nonce, so we don't need to bother with that. But what we do need is the nonce account. I'll just call it nonce here or whatever. And I'm gonna do an unchecked account. Trust me, bro. I know what I'm doing. I mean, probably Anchor knows how it's done. Hold on. But I don't know how to do it with Anchor. I want to tell it that it's a system program nonce account. But now whatever. I'm just gonna use unchecked and do it manually. Yeah. So we just need the nonce account. We could even drop the state. We just need that for checking success. So that's why we still need this and the index, such that we can check if it was successful, which we will need to know if we want to know if it failed or was successful. If we just want to check whether that transaction was executed, then we would just need the nonce account. But let's do both. So with the state, as before, we check that account was created and that we wrote something into the data. And if that's the case, then the transaction was successful. Okay, so far nothing new. But now, in case of we don't have success and we want to find out if the transaction was executed, we can check the nonce account, and maybe we read the nonce in here and compare it with the initial nonce. And I can put the entire 32 bytes of the nonce in here, or I could also just compare the first 8 bytes. That should definitely be enough, because even the first byte, it's very unlikely that the nonce, once it got advanced, will advance to the same first byte again, but it could be possible. If you want to save some space in the transaction, you could send less, but let's do the entire 32 bytes. And now we need to find out where in the account the nonce is stored. In Solana program system, program, oh, that's just the IDL. Oh yeah, the program is somewhere else. But then let's check Agave for programs, system, source. Where is that stuff? That also doesn't show it to me properly. Where is that? Do you have an interface? I could probably also find it out manually just by looking at it. Let's just Solana account this nonce account. It's got 80 bytes, can't be so difficult. State stuff, state stuff. when you call program nonce, can you give me the nonce? Yeah, now you want it as in, yeah, I'm gonna give you that again. Hold on, here. Have the correct type, have the address type again. Just wanna quickly read the nonce. That's byte. I would like to have it in hex. They're low enough numbers. What's a good one? We have a 1 and we have a 21. Those should be fairly easy to detect. 21 is 16 plus 5. So 1, 5 and 7 and 1. I will find 1, 5 and 7 and 1. Let's see. 1, 5 and 7 and 1. Okay, so 1, 5, let me guess, so it starts here. 1, 5, 1, 2, 3, 4 before. Yeah, 1, 2, 3, 4. So that is the nonce. Probably this is the authority, the D9, my fee payer, would also make sense. And then this is some other stuff here in the end. 4 plus 4 plus 32 is where the nonce starts. 4 plus 4 plus 32 is 40. 40. I take 40. So, nonce data, can I borrow your state, please? I don't need it mutable, just borrowed. Should I try borrow? Nah, just borrow, lol. Or we try borrow and then unwrap. Should work. I mean, I'm not doing anything with the unwrap anyway, so it should be the same thing. And then I want 40 to 48, and then I need to compare 8 bytes. So if my nonce is the same as the initial nonce, then does it work? Consider borrowing. Sure. There you go. Sure. Just compare. This is just, it will fail anyway or not, we'll see. If it's the same, then we can say the transaction with index was not yet executed. Else, we can say, since the nonce advanced, because it's not the same anymore, the transaction with index was executed and has failed. Because if it wouldn't have failed, then we would have gotten success up here. So this check is for, was it executed or not? And this check is, was it successful or not? You get the idea. Yeah. Logically, it would probably make more sense to do this first and say, hey, the transaction was not yet executed, and then say that transaction was executed, and then do the check whether or not the state changed was successful, and otherwise the transaction with index failed. There we go. That's what we can do. That's the nicer way to write it, probably. Okay, so let's see if that also works. So first of all, we gotta rebuild this. Then we gotta run Kodama again. Then we will need a new check. And instead of the initial fee payer stuff, we check for the initial nonce, which, since I don't know how to use nonce correctly here, I'm gonna do address, which, guys, don't do this. Please fix the kit. But anyway, I'm gonna put this thing, which is the current block hash, in here. And really, I'll get an address. I'm just gonna misuse the address encoder for encoding this block hash, which really is a nonce. Freaking gonna encode a nonce, but I don't have a nonce encoder, so I'll misuse the address encoder here, just to get from this base 58 string to 32 bytes. And then here, I'm gonna get a check nonce instruction with the same state, the index, we don't need the fee payer anymore, we don't need the initial but therefore we need the initial nonce, which will be this. Wait, what format do you need? The initial nonce is a read-only uint 8 array. That should be fine. Yeah, that should be fine. And the nonce, that's the account, that's just the same as this one. So that's the nonce account address. That should do it. And then we go to, I don't know, where were we? 4? So, yeah, 4. So, if we check, we should get a, damn it! That does not work yet, because it was not executed. We're not reading the state correctly, because it should still be there. Okay. So probably this thing, probably I can't really compare it directly like that, I would guess. Let's print that stuff. Let's print the nonce, and let's print the initial nonce. How do you do that? Something like that? No. Double point question mark. Yeah, that was it. Let's try it like this. And check again. Nonce in account. I'm just reading 8 bytes. I'm just reading 8 bytes. Of course. I mean, it would be enough, right? 8 bytes it's very unlikely that you advance the nonce. And even if an attacker could continuously advance it, it will still take him a lot of time to get to the same 8 bytes. So it would be fine if I just compared the first 8 bytes, but why not? Let's compare all the 32. So let's do 40 plus 32 because I'm lazy in calculating and compiler is better at that than my brain. So that way, that should be better. Redeploy this. Classic bug. I thought of 8, but it's 32 bytes, obviously. Yeah. My bad. And now, there we go. That looks better. And now that we're here, we could also, get rid of that debug output. But yeah, it does work. The transaction with index 4 was not yet executed because we didn't send it yet. So let's send it. Let's call the program with the transaction 4 and have it fail though. Call program nonce. So that was the nonce that was currently in there. But then the transaction was sent. And now if we check nonce, now it was executed and we say it failed. Why? Because that transaction changed the block hash in the nonce account. Because that transaction, even though it failed, it still did the system program advance nonce. And that way we could tell that this transaction was executed but failed because we didn't get success. We could do a 5 that we run with success and then the 5 here, but we would need to again start with the same block hash. So this we initialize now. We remember the state now before we do our transaction in question. So when we check it now, it should tell us, oh, I've got another. That's cool. I like errors because then I can learn what I'm doing wrong. Out of range for slice of length 0. Am I providing the wrong account? Oh, I changed the nonce account address and that's not a nonce account. Hold on. Wrong thing. I need to change this. That was my mistake. So here, yeah, that's better. Transaction with index 5 was not yet executed, but then if we execute it with success, there you go, it was executed successfully, and then I check again, then it will tell me, oh, it was executed because the nonce has a different block hash than I expected, and I can also check, oh, and this one it was successful because it did write to the state. And that, my friends, is how you can check if a transaction was executed and was successful or failed with nonce accounts. Also that, not an ideal solution because you will need to create a nonce account up front. You will always need to use the durable nonce lifetime, which in some cases just is not so ideal, especially if you let the user sign, because some wallets will create warnings because it has been used in attacks that some people did. Certainly not me. No, why would I do that? And yeah, it might make it a bit more messy. And especially if you have a lot of transactions that you want to check, then you need a lot of nonce accounts. Because as soon as you recycle the nonce account, you can't, unless you check the transaction if it failed, and then afterwards you can recycle it again, of course. But if there's many in parallel, then you just need many nonce accounts. So it will work, and it's relatively safe, I would say. In fact, I would argue it's like 100% reliable because only the authority can advance the nonce, so nobody can mess with that state either, only yourself. And if you use separate nonce accounts for every transaction, then you can check any transaction in the past if it still has the same. You just need to check the block hash before executing your transaction and compare it to that. Which again, also not ideal because you somehow need to get to that state when you call your program. So it's not trivial, like it's not an easy solution. Even that, I would say, is quite a hacky solution, but it will work. It will work reliably. And it's once again taking a Solana building block that's not intended for that. Nonce accounts are not intended for you to check if a transaction failed, but they can be misused for you to check if a transaction failed. But then again, the use case for checking whether a transaction was executed and failed is not that common, which is one reason why there is no better way to get that information. But yeah, there is no better way to get that information because we can't read the Solana ledger in the program. We can only read state. And with that, the nonce account, the block hash, is part of state. So there you go. That's my hacky solution. And that hacky solution even got me 50 bonus points of reputation. I'm now 900, so much reputation. Love it. 3 hours later. Yeah, it takes me a while to record videos, I know. But yeah, this is my implementation. I hope that helps. Again, it depends on your use case, what exactly you want to do. But that could certainly be one possibility how you get it sorted. All right, and with that, I shall leave you. Thank you for watching this little hacky tutorial. We did learn about Anchor, we did learn about Kodama, and we did learn about durable nonces and how we can check if a transaction failed, not just if it was successful. Because success is easy, failure is not. Take that as one of your motivational quotes and put it on your wall or on a t-shirt or whatever. Yeah. Cool. Well, yeah, that's a wrap. I don't have any better ideas. If you have any better ideas how to check whether or not a transaction was executed and therefore whether or not it failed, let me know. But I can't think of anything else. That's the only two things that I know a failing transaction will change in state. The fee payer lamperts and the durable nonce block hash, if it's a durable nonce transaction. And I'm actually quite proud of that solution. I feel smart for being able to come up with that solution. If you also think I'm smart, give me a like, subscribe if you haven't done that yet, and watch some other videos that I made about Solana development. And then I will see you in the next one. Until then, bye bye. Leave your questions on the Solana Stack Exchange so that I can find them and get inspired to make a video.